Okay, so as I've already said, we are going to really look at bringing together all of the pieces that we have gone through in the last couple of weeks. We've looked at, tooling. We've looked at chains. We've looked at MCP, and then we've finally arrived at agents, which, of course, an agent is basically an LLM that you give extra capabilities through tools, right? And you allow it to reason using the multi-step reasoning approaches. That's really what makes it an agent, right? But at the end of the day, how do these tools and agents, how does an agent with multiple tools, with RAGs and everything, how does it become useful in the real world? So we are going to talk about that today and some additional considerations when you're putting it on production server and you want people to start using it. So, of course, the objectives for today would be what are the things we now think about when we are designing a back end? So now this is for back end developers. But then again, if you're a developer and you're either building agents or you're using agents. Okay. So this is kind of the last place where we're talking about building agents. From next week, we'll go to Master AI, where we'll look at the front end, how we can use those agents as and incorporate them into our applications. So if you are designing an agentic backend, we'll talk about what's an agentic backend or real world production application, not just for demo or what we've been doing. And we'll look at what makes an agent production grade. We'll look at how to integrate tool services and memory. Well, we kind of did that already. So this is going to be more of hands-on using LangChain. And then we'll bring in a new aspect, which we haven't really talked about a lot. That is observability and debugging. And of course, the deployment is, we'll talk about that. But after you have deployed, you need to be able to see what's going on. And then we will perhaps at some time at the end of this week, look at um, advanced RAG, which is essentially we will build an application to use these all of the knowledge and capabilities that we have had. Okay, so okay. Okay, so designing agentic backends. Let's talk about what is an agentic backend. An agentic backend is a backend that accepts tasks, not just questions. So if you are using an LLM in the normal approach, you're using an LLM to ask questions and get answers, right? That's what it is. It's a chatbot, basically. But an agent is more than a chatbot. An agent becomes an executor, right? Maybe it doesn't actually do the execution itself, but it channels all of that. So you give agents tasks and it reasons around the task. It decides how to go about the task. It checks out the tools that you have given to it and decides which one to use and so on. So it does planning, with multi-step execution, either using the React or the plan and execute approach. And it uses the tools and APIs, right? And it maintains state. So essentially, an agentic backend is an endpoint that you have created or a backend that you have created that has an agent running or has the capability to run an agent whenever it is needed. That's what makes an agentic backend. So you could say that an agentic backend is similar to workflow engines or orchestrators or intelligent middleware, right? Well, so we also know what an agent is. What defines and differentiates an agent from maybe just an LLM is that an agent is able to do multi-step reasoning. Of course, an agent uses an LLM for the multi-step reasoning, but an agent has more than just an LLM in it. It has tools, right? It has state and memory, keeps states and memory. Because your LLM, while it can reason, it does not remember any previous conversations or any history. So it is incapable of keeping a continuous conversation, right? But the agent brings that by bringing state and memory. And then the agent, more importantly, has access to external system through tool calls, through API calls, and so on to um, connect to them. It also connects to RAG. So if you have a RAG as an external system, it's able to interact with that RAG and send data to it and take data out of it. So the agent is operating inside an entire software system, right? Of course. So, well, this is more or less a recap of what we've already done all these few weeks, right? The core components of an agentic backend is the same as the core component of an agent, but plus the back end part of it, which we'll look at it. So the LLM, which is used for reasoning and planning, right? That is part of the agent, the tool registry, right? And the tool calls, that's part of the agent. The memory system that allows you to keep state and history, right? That's still part of the agent system. The retrieval layer, which allows you to connect to vector databases, to RAGs and so on, and retrieve information that it doesn't have or it wasn't trained with, right? And then the execution loop, that's the last part of what makes it an age of what is in the agent. But the backend, in addition to all of that, will have observability and logging, which we'll talk about. Observability allows you to see what is going on inside the agent as it is going through all of these motions so that you can trace and track things that are going on, things that go wrong. You can debug if there are problems. There's one other thing that's not here, which is the infrastructure, the deployment, right? Okay, so you design, but after that, what happens, right? Um, do we just say, okay, in production, is it really the intelligence that is a key element there, right? Intelligence comes with the LLM. That's what makes, it AI. But now you have to add reliability. Reliability means consistency. It means, um, you know, transparency, right? And it means explainability. That is what the LLM or agent does. It should be we should be able to explain and understand why it did things the way it did, right? That's explainability. So these are the things that matter because when you are deploying a model, an AI, not just a model, you are deploying a whole system for an end user or for a business or for a company or for a corporate organization. It is not all the amazing things that LLM does that matters to them. The things that begin to matter to them are things like how reliable is this system? How repeatable is it, right? Determinism is much better, is far greater than creativity. Determinism means it it should give me responses or answers that are expected, that are deterministic, basically. In other words, for the same set of questions or requests or tasks, it should give me the same kind of, um, you know, um, responses or answers or execute the same way, right? There shouldn't be too much differences, which you say, oh, it's creativity. So take a good example of you want to refactor a code base and you're using a code refactoring agent, right? Or a coding agent. And then you tell it to do a bit of refactoring on your code base and it does it one way. Nice. You now ask it, okay, go and tweak this little thing. I don't like it this way. Just tweak it. And instead of just going to tweak that little thing, it actually goes to rework the whole code base in a different way. How would you like that? That is not good. So for you in production, you want something where the changes are small, focused on only that specific part of the code base that is in the scope or that is relevant. if you now have an LLM or an agent that goes around doing things, it keeps changing things the way it does things each time, it's not going to be good for you because each time you have to spend a lot of time trying to understand what it did and re-understand what it did. So that is a process that um, does not help productivity. Okay. So determinism is very key. It's in production. Yeah, there are some places where creativity may be very good, like if you are generating images or composing music and so on, right? But in the context of what we are talking about here, determinism is far better. The second thing is you want your tools to have explicit schemas because if your tool does not is not very clear in what it does and the parameters it takes, what it doesn't need to talk about how it does it. It's not the how that matters, it's the what. Once it is clear in what it does, then the agent is able to understand in which situations it should use that tool and in which situations it should not use that tool. So a good example is you make two tools. One is to get the weather, the other one is to get the temperature. And sometimes that may confuse an agent if you did not specify what those things do so that the agent knows in which situation to call on which tool. Okay. So that is what that explicit tool schemas does to it. Then we have guardrails around actions. So in AI terminology, you hear a lot about these guardrails, guardrails. Guardrails basically mean you have to limit what the AI does or where it goes to because you don't control the prompt, right? It reasons, it may generate prompts or it generates tools, it generates tool calls, and those tool calls come with the parameters. You may not control the parameters. So you have to apply guardrails where you have control. And in most cases, where you have control is in the tool calls themselves. So your guardrail allows or limits what LLM does. So it does not go and destroy your entire system or, destroy, you know, your organization, whatever you have built, right? So there have to be some things that will be off limits, and there have to be some things that will require human intervention and permission before it proceeds. Then timeouts and retries. These are very good, especially if we are writing two calls to ensure that the LLM doesn't waste too much time waiting because there may be demands for it to do other things, right? The second thing is retries help with the matter of robustness or reliability. If you have temporary failures, you don't just want to give up on the first try. There might be a temporary failure, network, connectivity issue and so on. You have to retry, and that improves the um, robustness and reliability of your system. Then, of course, you have to have the fallback strategies. We've talked about this already before, but I'm just bringing them up. A fallback strategy ensures that if one thing fails, there should be a fallback. For example, if you are going to do an LLM call, then you probably need to have a fallback to ensure that if that LLM call fails, okay, what do we do, right? How do we how do we manage it, right? How do we is there a fallback? Is there something else we can do, right? Or do we just shut it down and say, okay, we can't do this, and so on? So you see here that it says that most production agents fail due to unbounded autonomy. So you cannot just give an agent um, unbounded autonomy. It does whatever it likes without guardrails, right? And without very clear directions on what to do, including things like explicitness in schemas and things like that, right? Because when you give it unbounded autonomy, it may begin to hallucinate, go off the track, and actually fail to do what it needs to do. So integration is harder than reasoning. These days, in the past, reasoning was difficult because it was difficult for us to get anything that could actually reason. But now we know that LLMs can reason. So that has now become the easier part of the entire equation. You don't need to write code for reasoning, right, anymore. You just call out to an LLM, or whether it's locally installed or whether it's on an API. So that becomes the less difficult challenge now. The more difficult challenge is how you channel that reasoning properly. Okay. So the LLMs will reason well, but they do not enforce the rules. So you have to ensure that rules are enforced. Okay. Um, your prompts have to be very clear and explicit, and so on. External systems are stateful. This stateful means that they retain the previous state. They have permissions and they're failure prone. So these are the things you need to be aware of and ensure that your agents will operate within those boundaries. Because once you are not able to constrain the agents to operate within the system boundaries, they will damage, and destroy stuff. Okay, so let's talk a little bit of how you can integrate agents into the external systems. MCP is basically it, right? It allows you to do that. Of course, you can write your own tools. So building your own tools or using existing tools have been built. Anyway, MCP basically allows you to use existing tools that have been built. So the common external systems agents will interact with the APIs, the third party software as a service. Most things will be software. And you need to start asking yourself things like CRM payments and such. Do you want your agents to directly initiate, actions on this, you know, into these externally connected systems? Payments is a very interesting one, right? So it's something worth checking. In some of these cases, you may want to have a human approval before the agent, you know, initiates the connection. Databases, you have read only analytics where you can read data from database. You can do metadata lookups. Other kinds of external systems, enterprise systems like the ERP. So you could actually have an agent that connects to an ERP and pulls data and so on. Document management systems, ticketing systems, and so on. Then infrastructure services like queues and schedulers and file storage. So these are all things that your agent can integrate and interact with. So typically, in such situation, the recommended pattern for you to follow is what we call a service boundary integration. So you have an agent, right? The agent calls the tool. Of course, the agent has the LLM running inside it that essentially handles the reasoning. A tool is selected. You now have a tool call. Then you have a service layer. So the service layer is what brings about the service boundary. And then you have the system where the tool call actually operates. So you can see that we kind of separate the tool away from the system that the tool will act upon. Of course, this is in the enterprise. Recently, people have been talking about Claudebot. And Claudebot is basically an agent, a chatbot agent that runs on your laptop or desktop or on your system directly and can do stuff on your system. Of course, we are moving to that point where operating systems will become intelligent agents, essentially. Um, but there are questions around that. For example, it is still calling out to the Claude API for LLM, all right? As it's calling out, what data is it carrying along with, those API calls? Any data, anything you ask it to do, of course, it needs that data to query so that the LLM at the back end, by the LLM provider can reason about it. So you now have data leakage. Is that something that's acceptable? You'll find that a lot of different enterprises that you may go to provide service as an AI engineer or AI developer, build this or that, they will ask you, how are you going to protect my data, from getting leaked out to the LLM itself, where it is? But the other issue is how are you going to ensure that you minimize we still maintain the standard um security, safety, access control that we have. So the service layer introduces validation, right? It allows validation, it allows authorization, rate limiting, error handling, auditing, and logging. So all of that, we can implement all of that in this service layer. And the beauty of that is that you can reuse this service layer for multiple systems. Okay, because everything is all about reusability, integration, scaling, horizontal scaling. So if I build a service layer and ensure that whatever tool call is validated, you validate the tool call, you validate the arguments that are coming in, right? So for example, if you say get me the weather in London or in a city, you ensure that that city actually exists. It's not a non-existent phantom city or something. That's validation. Authorization, is this particular tool call permitted? The person that is behind it, is it permitted? So there are methods of authorization. Of course, most cases we use API keys and so on. So you could even introduce API keys. And I'm sure that will come in with MCP and tool calls. Before you're able to access this system needs to be the call needs to be authenticated. So the same way authenticated and then authorized. So the same way that you do that in any normal API access. Because if normally you were doing it as a human being rather than a tool call from an agent, you would have to authenticate yourself, maybe put in a password or JWT, JW token or something, or a path, right? So this still does the same thing even for agentic calls, right? Then rate limiting. So rate limiting is important because you could have what we call the distributed denial of service or even a regular denial of service attack, where you continue to hammer this system with so much request that the system collapses and crashes. So rate limiting helps to limit overload of a system, but it also ensures that you don't exceed your compute that you paid for, because in some cases, some of these API calls may be things you pay for. So to just ensure that you don't exceed what was paid for, right? So you do rate limiting. Error handling, of course, you have to do handling to gracefully, exit if there are issues. Auditing and logging, this is also very important. There are regulations and regulatory requirements around observability, explainability. So whatever agents are doing, we should be able to see what they have done. If there's an audit later on, there should be an audit trail. So there should be auditing and logging, right? So the agent will usually request, something, but the service is what actually executes the requests. It's not the agent. So, um, yeah, let's look at after this. So let's talk about some of the things to consider when you are integrating agents with external systems. The first one is your services. In other words, the services are providing, um, the uh, the tool calls, right? They should be designed to be agent friendly, right? And what does agent friendly mean? The API should be task oriented. In other words, the very name that you give, right? Because the agent can deduce from the name you give. So this is where self-documenting code and APIs are very important, right? If what the um, endpoint in your API, what is doing is creating an invoice, but you call it something like um, you know, you give it a cryptic name, the agent may not be able to figure it out. So it makes sense to use this kind of nomenclature, create invoice, search documents, and then you even have a um, very clear and self-explanatory names for the parameters as well. Okay. So that's the first thing. Second thing is avoid exposing raw details of implementation in your API. Of course, a standard um this is a standard principle, right? It's what we call information hiding or encapsulation. When you are coding, you don't need to see the the user or caller of an API or function doesn't need to see the how of how you did it. They only need to see the what or know what this function does, right? That's all. They don't need to know how it was done. So the raw SQL queries and things like that shouldn't be exposed. The low-level CRUD, shouldn't be exposed. And you also need to be careful that even in the situation where there's an error and a crash, your endpoint that you wrote, your service endpoint this time around, doesn't vomit, the details of its implementation. I see this happen, especially for those who use PHP and so on to write code. When it crashes, a whole thing just comes through, including database credentials or database schema and so on. Those are not very safe, right? So this is a general principle, generally. Then your responses should also be structured and predictable and minimal. Minimal because it helps with context window size. Okay, if your results are too verbose, you overload the context window of the agent that's consuming that. It should also be predictable, and of course, it should be structured. So how the other thing is, how do you handle failure and uncertainty? So we talked about that already. So external systems will often fail with timeouts, partial results, and rate limits. So you have to be able to handle this. Timeouts, like we said before, you have some retries, but you have a limited number of retries. At least for temporal failures, retries will help, right? Then if you have partial results, you should have validation. And you should decide what to do with partial results. Do we terminate the whole process or do we send it back to the LLM and ask the LLM to decide and reason about it, whether it can continue with the partial results or not? So, you know, that there has to be a way of representing that this is partial results. That's the main thing for someone that is writing a tool or an endpoint that will be used as a tool. Then rate limits, we talked about that as well. So, design tools to return explicit error states. Yes, your tool should return explicit error states. Your tool should support retries, and there should be alternate fallback, paths. So it's not a good idea to let the LLM be the one to guess how to recover from a failure or whether it was even a failure or what the failure was, right? All of that information should be provided. Okay. Even when you want the LLM to reason about it and decide how to respond to the failure, but you need to give it sufficient information about the failure. So that means your error messages should be very clear. Do not combine and conflate and confuse multiple error messages. In fact, there are some people like when you write an endpoint for login, and somebody types either the wrong username or wrong password, you now say invalid credentials. So that's not really good in this context. It would be better to let it know that it is either invalid email or invalid password or invalid username, right? uh That's much better than saying invalid credentials. I do that. I'm guilty of that myself. Okay, so the other thing with integrating agents with external systems is what we call idempotency and safety. I've mentioned this before. Tools should be idempotent. Idempotent means if I make a request, it gives me an answer. If I make the same request, it should give me the same answer. Also, if I ask it to change state, right? Maybe if I do multiple requesting that are the same, right? Multiple identical requests. The state of the system should not change because the state of the system should depend on what I have asked the system to do. So, for example, if you ask the system to say, okay, set X equals to 10, and I send that request multiple times, at the end of the day, X should still be equals to 10 and nothing else should change, right? But a non-idempotent system would be a system where I said set X equals to 10. And if I send that request three times, X might still be 10, but Y will now be 3. If I send that request 12 times, X will be 10 and Y will be 12. Well, if you're using Y as a counter, maybe for rate limiting or something, that's okay, but that should be an internal detail that is not part of the external interface, right? So that's what idempotent means. Now, we're not saying that the internal state may not change. It might change. For example, you want to count how many times the same request has been made, but that is should be not necessarily part of the external interface. Um, yeah, tools should be side effect aware. So if there are side effects to a tool call, right, the tool should know about it. And a good example is what I just mentioned. Like if you are changing one thing and it affects something else, or maybe you are setting X equals to 10 and then you load the database or you load the cache. A side effect is typically something else that happens that changes the state and is persistent. So yes, this is a good example. Separate something like preview action and execute action because preview action does not have a side effect. Preview action is view only. You are seeing something that's going on. Execute action has a side effect because execute action may change something. So preview action will be idempotent because no matter how many times you preview, nothing changes. It's still the same. But execute action may not necessarily be idempotent, even though you could have an execute action that's idempotent because it keeps, when you say execute action, you specify the action, it does that, and it has the end state. These are concepts in software design, which I would encourage everyone to go check out. So a good example is quote, confirm the quote, and then execute payment. Yes, this is a very good example. Now, what if I sent the same quote a second time? Or I do a subscription for January, right? And I make payment for a January subscription, and it executes the payment and deducts money from my account. Then I come back later, I did not notice, or for some reason, maybe it's a bug or a failure, it does not show me, it does not update my own side and show me that. In fact, a really good example of that is an agent makes a request, or even a regular person, you make a request to make payments for a subscription and you successfully get that done. The payment is successful, the subscription is successful, but you don't get a response because something fails before you get the response. Maybe the system crashes or something, and you don't get a response. So you don't know that your payment has succeeded. So what do? You initiate another subscription again and another payment. And the idempotent system will see that you had already made the previous subscription and it was successful. It will not make another subscription again. It will rather tell you this payment has been done already and give you an updated status, which will now reflect on your own side, whether the agent side or the user, right? But a non-idempotent system will do a second subscription, basically repeating that subscription for that month, okay, and making another payment. So that is the difference. The other thing is what we call observability, which we are going to talk about. Observability, you should be able to see what is going on. So at the point of integration, where the external system is integrated in, you should have a logging that logs the tool inputs, the tool outputs, and the errors. This is very important for observability. You should also have traces. A trace is what we may call a stack trace, right? That allows you to see, the history of the, the code execution, basically. And the trace allows you to know where it fails and, at which reasoning step it's failed. Okay. So this is part of observability, which we are going to look at. The traces will be fed into Langsmith. Langsmith is an observability debugging tool that is built by the same guys that build LangChain, so that it's easy for you to analyze your your production um, system basically. while it is running in production. Okay. And you can figure out if things go wrong. You can monitor and analyze. And then you also have existing APM tools, which are basically the same thing. So that is kind of the summary of the good principles to follow when you are moving your code or your agent from just prototyping and trying to um, putting it in production, right? So don't worry, we're going to look at Langserve and Langsmith. If we don't do that today, we'll look at it this week. And you know what Langsmith actually looks like. Okay, so the next thing we want to talk about, if there is no other question, is having completed building your API, your agentic tool. How do you deploy it? What are the ways to deploy it into a backend so that it's accessible? So we'll just talk about that, but we'll do more of hands-on, but I just want to run through the slides. Okay, so why would you serve your AI agent as a backend instead of just running it maybe on the front end as code? Mainly because you want to decouple the front end from the model. You want to decouple the use of a model from the model itself. That allows for you to achieve scaling, right? It allows for you to achieve security, and it allows for you to achieve observability, right? Which we'll look at shortly. And it allows you to achieve reusability is a main thing. So imagine if you built a very nice agent and you embed it in a single app. Then if you needed that same agent in another app, what would you do? Would you make a copy of that agent, right? Or will you rewrite the whole thing from scratch? It's not a good idea. So it would be best to say, okay, I have an agent. Let me deploy it as an API, right? As a backend, so that if I need it for this front end, I call it. And if I need it for another use, I call it. Okay. And eventually your agent becomes, something else, another tool that, another agent can even use. So, um, it's actually, we are going to look at how to, um, deploy with LangChain, normal LangChain deployment with fast API. And then we're also going to look at normal, uh, using LangServe and what LangServe, gives to us. But I think the main thing is, if you look at this, you see that, um, you would still have to do all of this, right? App.post kind of thing if you're using fast API, and then you run the chain, okay? And then you get the responses. But if you're using LangServe, you can see the code is much easier, right? You just use add routes and then you specify the app, you specify the chain, and then you specify the path. What the beauty of using LangServe is that LangServe will automatically expose chains as APIs or runnables in general. So even agents will be exposed as APIs, right? And then LangServe has built-in schema. So in this case, we had to use a Pydantic based model here to define, the schema for the inputs that will come, right? But with LangServe, it has its own built-in schema, still using the same Pydantic, but you don't have to worry about it, right? Because you're using built-in LangChain structures, data structures. LangServe gives streaming support. Streaming is very, very important with AI because sometimes the AI, you need the response, you need to begin to stream the response. Now, imagine if you had to implement streaming by yourself. Well, you still could do that. Fast API allows you to return streaming responses. It's not really that difficult, right? But then the fact that you have to keep doing it every time versus LangServe just does it for you. Okay. That's different. That's different, right? Then easy deployment. So these are the things, to look at. So if we want to deploy to production, there are some things that you want to ensure that they are in place. So the first one is um, request tracing. In fact, tracing and observability is very important, right? So you want to be able to trace requests. so that if something fails, you want to be able to know what failed and why. Okay. So it's very important. But the other thing is, um, it's difficult for you to do tracing on your own. Um, and these days, there's something we call open telemetry, which has become a standard for tracing. We're not going to delve into all of that, but it's something I would encourage you to go and check out. Check out. Okay. The other thing is token usage logging. You know, if of course, if you are building a backend and you are calling the LLM, you have to ask the user to insert their own token because you're not going to pay for the user to use your tool or your agent. So the LLM calls, you use the user's token. And not just LLM calls, any other API calls. If you're using a RAG and you're using a vector store and you're using maybe a production SaaS like Pinecone, okay, they have to include tokens for that. If you're using embedding models and so on, so all of that, right? All the token usage needs to be logged. In fact, you will notice that if you go to some of these AI providers, you see that when you create a token, below it, you see where it tells you the number of times that token has been used. So you want to also be able to trace and track token usage. You know, is very, very critical. Again, just for um, just for should I say transparency, the user needs to know, right? And all of that. So token usage, you need to be able to trace it and log it. Then timeouts and retries, it's good to also trace and log all of that. Then rate limiting, okay? Then model fallback. So these are some of the must-haves. Um, this is kind of you know, a recommendation. It's not cast in stone. There are other ways you could organize your back end, right? But typically, you would have your main entry point. Okay. Like me, I would have a main.py. And then from this main.py, you can have agents, you can then have tools, you have a subfolder for tools. Each tool is implemented separately. Um, all of the examples we have been doing, we have been using one-line tools, simple tools, right? But those are just for, learning and demonstration. But in the real world, your tools may take entire, you know, uh, 100, 1,000 lines of code to implement, right? So these are the tools. Then schemas, where you can keep all kinds of schemas. And you have server. Server is the entry point in this case, right? That kicks everything off. This is where you can implement memory and config. Um, the other thing I didn't even mention here is things like queries. If you have chains that are built on prompts and prompt templates and all of that, you could also do that. But in most cases, agents, you don't really need to do a lot of prompts for agents because agents, um, the way LangChain implements it, a lot of those prompts are internal and have been optimized, right? But most other things, the agent basically reasons about it, the LLM reasons about it and comes up with something. Okay, then, so at the end of the day, the LangServe deploys runnables, not just chains. Agents are just stateful runnables. Okay, so APIs must be type stateless and observable. Okay, so the main thing to remember is that the um your deployed model or your model backend is not a user interface. It is something you will later on connect to a user interface that you will call. So having said this, I'm going to do it hands-on, but I'm going to split it into two. I will come back to traceability, tracing and observability, where we'll talk about Langsmith. But let us first of all just do a simple deployment with LangServe. So for that, I already have something I had started doing. I'm going to um, quickly um, I'm going to quickly just pull it and do just a simple endpoint. I'm not going to do anything complicated yet, just a simple endpoint. And what I did was I have a code space. I have a code space, and I'm going to share my screen to show you that code space. And I did a bit of work already on it. So it's a lang serve example. Sometimes it takes time to load up. Okay, well, while this is loading up, let's look at tracing and observability. Let's get back to look at this. Okay. And then we will resume when this finishes loading up. So let's talk a little bit about tracing and observability. Tracing observability basically refers to your ability to monitor and measure and analyze the behavior and performance or an output of AI systems. And it's really not just AI systems, any system in particular, right? Observability basically refers to any system that you build, being able to observe it and, see how it behaves. And not just see how it behaves, but um, use that as a means to debug. Okay. So it provides visibility into the internal workings of complex machine learning models and large language models. And it enables developers to be able to detect issues. For example, model drift, data quality degradation, and biases. So the developers can then respond to ensure reliable, accurate, and cost-effective production performance. So the thing is, in production, you don't have the opportunity to go and change your code, for example, and type in things like print or console.log. It's not possible for you to do that in production. So you have to find a way where you hook into the app. And while the app is running, you can be monitoring it elsewhere without interfering with the proper operation of the app, right? This is the main thing. This is really what observability does for you. Once you implement observability, it allows you to be able to say, okay, let me check what is going on here. And, from there, I can figure out if something is wrong or not. Okay. It's very, very important. So if if you are not able to do that, then you'll be in a lot of trouble because it means that when your system fails, you essentially be running around like a headless chicken trying to figure out what to do. Okay. So we're going to look at there are tools to help us do that. APM, Grafana allows you to plot graphs. So that's not what it really does, but open telemetry is another. Open telemetry is an entire standard. In fact, everyone these days uses um, open telemetry, and there are hooks into it from all of the different observability providers. Okay, so the importance, like I said, it is also very important to ensure trust, compliance, and efficiency for AI applications that you deploy at scale because you need to see what's going on, right? If not, nobody will trust even you will not trust what the AI is doing, okay? So some of the key aspects of AI observability is that beyond the traditional monitoring that we are doing, right? Monitoring tells you if a system is broken, but observability tells you why it is broken by examining telemetry data. So observability goes beyond monitoring. It you collect additional data. You collect more data with observability than you would collect normally. Okay. So the purpose of the additional data is to allow you to understand not just whether a system has failed or what has failed, but also understand why it failed because you can trace. So the three key elements of observability are the logs, which are the log files, the traces, which are stack traces, but it goes beyond stack traces because a stack trace is a trace that is happening within the application. But traces also go beyond the boundaries of the application to what comes in from the outside, including requests, right? And then what goes to databases and comes back. So traces go all the way. And then metrics. Metrics are used to measure, they are basically performance measures of the system entirely, including things like, for example, CPU speed, CPU um, um, loading, percentage loading, um, bandwidth. Those are metrics. Metrics are essentially measures of the different elements of a system, hard drive space, memory, size of RAM that's been used, size of RAM that's available. Those are metrics, right? So those are the difference between logs, traces, and metrics. So, yeah, that's the first. The second thing is that in the case of AI, there are unique challenges that you have to deal with, which are not there in traditional software, right? Traditional software fails and you can know that it fails because it's kind of very deterministic, hard-coded, rule-based systems and all of that. But AI models, especially generative AI models, can fail silently. They will hallucinate or they just fail silently and give you a bad result or a biased result. And it doesn't crash the system. So the worst part of AI systems is that it can give you, instead of telling you, how do I put it now? Instead of telling you a lie, it can tell a half truth, right? And you cannot differentiate between that and a lie. Okay. So you go with it. Then, so that's a unique challenge, right? So the core components that you think about, when you're thinking about observability and the things that can go wrong, the data drift. For example, you train the model on training data that you got, some probably training data is old. You now have production data that comes in. If the production data deviates from the training data, that's what we call data drift. The model performance will get worse and worse because it is now seeing new data. Um, it has to work with new data that it wasn't trained on. So you need to know about that and figure out what to do, whether to refresh the model and, retrain it or something, or fine tune it or something. The model performance, tracking the accuracy, latency, and throughput. Explainability. Explainability is basically, like I said, it should be possible, easy, and not just possible, easy for a human being to understand how a model arrived at a particular decision or output. Okay. Then pipeline tracking is tracing the flow from the user input to the final input from or final output from the AI. So that's observability. And for us to achieve observability, we use Langsmith. Langsmith. So let's talk a little bit about Langsmith before I go back to the hands-on. Langsmith is basically a tool. It's a development platform and it was created by LangChain. It allows you to debug and test and evaluate and monitor your LLMs. So it gives you the whole 9 yards, right? Debugging, testing, evaluating, monitoring, and it gives you usage metrics. It acts as a flight recorder. So essentially, that's the observability. It records everything that happens, right? Um, I'm sure it uses open telemetry protocol. So it's a flight recorder. It records it. You hook it in. it's a platform that you create an account in, and then you create um you attach, you set it up with some, we are going to see how it's done anyway. You set it up and then it's able to connect into your application, and your application will send data to it essentially. So it provides visibility into complex non-deterministic or black box LLM chains. So there are a lot of things that are going on inside LLMs because LangChain is, the agents are built by LangChain. You have the React loops, you have the plan and execute, you have the chains. These things are generating, prompts, queries, and all tool calls and all of that, right? So all of these things are sent as information into Langsmith where you can view them. So you don't need to go and be doing console.log or print or logger.info and all of that, right? Because that is interfering. That's you going back to play around with code that's already in production, which is not a good idea. Rather, this information is sent somewhere else and you can view all of that. It is framework agnostic, but it's optimized for LangChain and LangGraph. Okay. So use LangChain for prototyping, use LangSmith for production. So we'll look at some of the key capabilities. LangSmith can help with debugging and tracing, like I said. So it allows you to trace individual requests through an application. You can inspect exactly how the LLM tools or prompt chains behaved to identify the root cause of errors or high latency. Um, you can create evaluation and testing data sets to run some systematic tests through your agents. Basically, you can do different variants of prompts or try different models, basically set up different tests, and then you run them and then you measure how your agent, performs. That's what we call evaluation or evaling, right? So it allows us to do data-driven comparisons to ensure that your models still maintain the high quality, consistent outputs. And if they don't, then you can use your debugging and tracing to figure out why and fix things. Of course, it also allows you to do monitoring and analytics. Langsmith will provide real-time dashboard that you can use to track the metrics, like I said, such as latency, cost, and success rates, and also to view, performance. It has annotation queues, so teams can manage and curate data. You can provide manual or AI-assisted feedback on specific traces to improve prompt engineering or fine-tune models. And it integrates directly with LangChain. So you have end-to-end visibility. So once you have done all your stuff in LangChain and you deploy, right? From the initial prototyping, once you deploy, Langsmith takes over and allows you to view how your application is performing. So Langsmith is designed to help developers transition from simple, unpredictable prototypes that you just did to reliable production-ready AI systems. So I will come back to this later on, okay? But let's just look at I will come back to this and maybe just do a bit of what do you do with Langsmith, okay? So let's switch back into this other screen where we will look at the um I have created I've created the a code space. A code space, well, GitHub code spaces, so you can do that. It's very easy. Everyone has access to it. Once you create a new repo, so for example, this is my work thing. I've already done LangChain agents then, and I'm now doing a LangServe example. You can, when you open a repo like this, you can actually open it in code space. And the easy way is if you're in this repo, You click on it and then you can go to code spaces. So when you click on code spaces, you will see I have a bunch of them already, but you can always start a new code space. So I have a bunch of them already. So that's you can click new code space here to create new code space. Then you specify the repo that you want to connect to, and that's how you create code spaces. It's essentially a virtual machine that GitHub provisions for you, and for free for a limited amount of credits per month, which you can then use. So here I am going to follow, there was an example where we showed how I want to build I want to use this as a template to build a production grade AI agent um, back end, essentially. So we are going to have the RAG. Remember, I did a tool augmented RAG that time. So I'm going to, but that was done on a Jupyter notebook. And because it was done on a Jupyter notebook, I could not, I can't run endpoints on a Jupyter notebook. So I moved it to code space. Right. So I'm going to essentially, for the sake of speed, I'm going to borrow a lot of code from there. But the way I structured my code is I started off with the main.py. So this starts with basic fast API. Then I have already brought in langserve. So we're going to use langserve. Langserve allows you to use add routes like I showed that time. You use add routes from langserve. And when you do this, it gives you three routes, basically. When you use add routes from langserve, it gives you three routes. It gives you the normal route, then it gives you a streaming route, and then it gives you a third one. We're going to look at it. So I have already created two here. Then I created helper functions. This one is going to create an agent, and this one is going to create a RAG, right? Um, okay, so we start from here. So the first thing I want to do is let's set up an agent first. So I have a a file here where I have the agent, right? So let's start again. Main, if I control click here, it takes me here. The agent is this is just a helper function that assembles agents or creates an agent. So we use a create agent function, and I have another function where I have the LLM, and then I have memory separate, and then I have tools separate. Right. Now, tools, for now, I put tools in a single file. But when the number of tools increase, I could create a whole folder and put each one in a separate file here and import them or export them separately. But for now, we just have tools in here. Right. The tools I have defined, right? Just a calculator tool, a search notes tool, and then I have this function get tools that brings the two of them together and returns it. Okay. So that is what I am calling from the agent um, class. I could have put all of this together in a single file, by the way, but I'm trying to give us an idea of um, putting them in different files helps in organizing things, right? Even though I'm also the first person that will tell you, keep it simple. If we were doing, like if I ask you to do a task for me, which is just a demo for just a demo, I will tell you put all of this in one file. It doesn't make sense to split it across so many files. I'll put it all in one file, right? And make it work. Maybe that's what I should even do. Okay. Put it all in one file and make it work. But in when you are building large scale stuff, you find that the things begin to grow. So all of this cannot fit into one file, right? So that's the purpose for all of this separation. Okay, we have the LLM. The LLM allows me to basically swap out LLM. So for now, we're just using Chat OpenAI, which again we get from long chains chat models. Okay. And but we are using open router. So on this is how we get open router. I already created a .m file where I have put two environment variables. The first one is the open router API key, and the second one is LLM model ID. So um so from my llm.py, which I use just to pull LLMs, okay, you will see that each time I get LLM, I load .m. This is to ensure that I'm always getting the latest um, environment variables. Otherwise, I may be using a stale one in case the environment variable gets changed. Okay, load.env is imported from .env. Okay, so with this, if the LLM model ID is specified, like in this case, then I'll use that. But if it is not specified, then what I'll do is I will default fall back to the Nemotron 3 nano 30 block, right? Even though that's still what I put in here, but this allows me to use a different one. Okay, temperature zero. Temperature zero is very key. Remember we said deterministic or determinism. If you increase temperature, the LLM will begin to look for, more creative ways, whether they are good or not. Okay. So this is very simple. So you can see how we encapsulate everything. Now, so let's start with, basic stuff. I'm not doing RAG yet or vector store. Okay. I'm just doing like basic agent stuff. So let's get that going. I'm even going to take out this RAG for now. Let me take out this RAG and yeah, let me take out this RAG roots. Okay. Now, um the interesting thing is I did run some test coverage, but I'm not going to go into all of that. Test coverage got really complicated. I just want to run this on UVCon. Okay, but first, of course, you have to do of course, remember you have to do a virtual environment, which is Python-m vm. Okay. And then you source that virtual environment being activate. You activate that virtual environment. So we are there now. I have activated it, and I think all my requirements are installed. I have all my requirements in here, right? Um, LangChain, LangServe, LangSmith, LangChain Community, LangChain Classic, OpenAI for the OpenAI client, Phi CPU. I'm going to change Phi's and switch to, um, well, maybe I'll use Phi's, but we'll see how difficult. If it gets too difficult, I'll switch to what do you call it? ChromaDB. Um, then so let's start with basic agent first. No RAG, just basic agent. So UVCon um app app.main app. We can do reload if we want. Yeah. All right. So remember when you are on this, it is okay. So I already have a problem here. So let's see what this is. Um so I didn't use the right thing here. Yeah. This is always, I keep having this challenge with LangChain, old version versus new. So let me go check um, where to get this. I know I have done this before. So yeah. Chat OpenAI is no more in chat models, it's LangChain OpenAI. All right, that's where we get that from. So we have to add that into our requirements. Okay. We should even have LangChain files as well. So let's pip install that. I'll just do requirements of text. It will only install what it needs to install. Okay. So Okay. So we'll run UV again, and let's see if anything else goes wrong. Memory, conversation buffer. So I might avoid this for now. Conversation buffer is using the old API. So I will, let me even see where that is. Um, memory. Oh yeah. I'm just going to comment this out for now. I don't even know where it is being imported from. Oh, we are using it for the agent. I'll ignore that for now. We'll do it in steps. Okay, so okay. Create agent doesn't have variables. So the main reason why I'm having all of this challenge is because I asked my agent here to generate the code for me, and this is Copilot. Copilot is um the recent version of LangChain, it's trained on older data, so its data that it was trained on is not up to date. So that's why it's generating wrong code basically. Um yeah, so these are some of the issues with using agents. You have to be careful. All right, so finally this works, right? So you can see that LangServe has come up and it has told us that it is there, it is alive. I am LangServe, and you have agent playground. So you can see that we have route for agent, and it's even agent playground, which is interesting. I'd like to see what that does. All the available routes are at docs. So if you want to see this, right, this is on port port 8000. I ran it because I didn't specify a port number, so Unicon just went with port 8000 by default. So this port 8000, for me to view it externally, I go to the ports tab here. Okay. So the first thing you have to do is to make this port a public visibility so that I can view it from outside of this code space. So I'm going to right click here and change port visibility from private to public. So once I do that, it will restart and it's now public. Then this is the link that I'll use to access it. So I'll hover over it. You can either right click and copy. There's no copy here. If you hover over it, you see this thing here, copy local address. So I'll click on it to copy it, and then I can go elsewhere. Let me close this. I can go here and paste, or like if you are using a mouse, you see paste and go, and it will take me to that. So it gives me this warning that I am about to access a development port served by someone's code space. Of course, I know it's my own code space. They're not going to do anything funny because the essence for this warning is somebody could use a code space to clone like a Zenith Bank or some other bank or somewhere where you go and put in your credit card, right? And they'll use it and charge, they'll chop your money or something. So you have to it's just giving you this warning that um it's not a certified site. But yeah, I'm the one that created it, so I know. So this is Swagger, right? And it's giving me a status AI backend running. By the way, this status AI backend running comes directly from this, see this endpoint. This is it, all right? That's the response when you go to the default um route, which is slash, okay? So it's giving me that, and it's supposed to be a JSON output response. So the browser is getting a JSON output response, but it's just printing it here. But anyway, I'm looking for documentation. So on a fast API backend, you use docs/docs to get documentation. So this will give you swagger of the endpoints that currently exist. So you will see that just using lang serve, right? This is the only thing I did, add routes. And the path is slash agent. So we are going to have slash agent, this and that and that. Lang serve has generated additional, all of these routes, with that single call, right? With that single call. We have input schema, okay. Output schema, config schema, invoke to invoke the agent, batch to batch invoke the agent, stream to invoke the agent as a stream log, right? Stream events. So langserve is what did all of this for me. Okay. Then langserve also added this agent slash config, okay, which allows you to do some kind of configuration. So you can get the input schema with config, output schema, the same. It's basically the same endpoints as this, but with config. And then this is the default. The get that I just did. This is the only one I did. Then the token feedback, again, created by LangChain. So LangChain, and then all of this type, pedantic validation types, again, created by LangChain. Sorry, LangServe. So LangServe simplifies things for us. So if you're not like a hardcore fast API backend person like me, you'll be very happy with this, right? It just works. Okay, so let's look at a few of these things. So if I want to get this, right, I can just click on try it out. There is no authentication yet, so I just run execute and it gives me response. So this gives me the input schema, how it should look like. Okay. This is something that you can use in the case of you want to convert this to an MCP. Effectively, what this input schema and output schema does is to make your endpoints conformant with MCP. And we're going to look at that when we look at the requirements for MCP later on. But you see, response body, it's even an AI message and all of that. This is a response that you get. Okay. So you don't need to do too much work. You even see a tool call chunk and all of that. So this is input schema. Now, output schema, you also see that I can run again just to get the output schema, how it looks like. And again, it is AI message, right? AI message is returned from a chat model as a response to a prompt. So this again is a schema that so in case you want to do some kind of validation against the input and output schema, right? You can use this. Then this is config schema. So again, I can try it out and try the endpoint. All of these are just giving me schema. This is not actually querying the agent. Okay. Here you have a response body. This is the config schema. So you have a title, lang graph config, and the type is object. This is all we have from it so far. Okay. Now this is the meat of the thing. You can invoke the agent now. And this is the input. You specify the input, which is the messages, right? So remember how we were calling messages, we were calling agent that time, we'll pass in messages as a dictionary, right? As part of the input dictionary. And the messages is a list. So it has a list of things which can be either AI message, human message, chat message, system message, function message, tool message, AI message chunk, and then chunks, right? So basically the same schema as you would have used. Then you can pass in some additional config, right? and then the keyword argument. So this is a schema if you want to invoke the agent. So let's try it out. Um, I so it's going to work because I have set up my Open Router API keys. I set up a bunch of tool calls. Okay, so I can ask it for something. For example, what is the sum of you know 3 and 2? Okay, so let's try to do that. Um, config hash um, string query. So this is a request body. I don't know if I need to put a config hash, but I'll just leave it. It's something you have to. I think it's a command line parameter in case you want to specify some particular config. But if I want to send an actual request, then I will use this. And it's giving me such a detailed stuff. So you have input messages. The first one will be content. And then I don't need this. So let's just say I only want to send one message. Um, I'm not going to put all this additional stuff. These ones are not required. Type is human. Type should be human, but we can assume, right? Um, they're just kind of giving us examples of this. But a very simple one is just this content and type, which is what we were doing before. So I don't think I need to do all of these other ones, two calls and all of that. I'll make the type to be um, yeah, so type should be human, and that is it. I am not going to. And by the way, this is JSON, so we cannot have hanging commas. So this is the message, it's just one message. The content, I'll type in the prompt shortly. The type is human. And then config, there's no config. KW args, there's no KW args. So I just pass this in empty stuff. So the content, which is a prompt, is going to be something like, what is the square root of 33? Now, there will be a tool call and all of that. We'll see the entire response from this, right? So I've built an endpoint. It gives me a response. It does with call. Okay, so we have 500 internal server error. Let me go check out what that is. So I come back here and I will check my terminal where I'll see what the error is. So it says invalid request error, code invalid API key. Okay. So what has happened is that Open Router, probably my key has expired. So let me go get a new key. Let me go get a new key. Uh, okay, so I have a new key I just created. So I'm going to use that. Of course, I have to put in my .m file and um, hopefully Uvicon will reload. If it doesn't reload, I am going to assume, I hope that remember I said when I was writing this, the get LLM, it's actually going to always load .m. So it's always going to get a new instance of it. So anyway, let's try it now again. So I try this again to execute, and let's see what we get. Right. We still get a 500. Um, the error is still invalid key. So I'm going to assume that that key was not picked up. So I'm going to reload. Okay. Yes, I can try again. Execute. Okay, so now I have a 401 and I don't know why I have a 401. Okay, I know why I have a 401. I need to check the port because I restarted. My port is back to being private, so I need to change it back to public. So the 401 is from my own side. It's not from um okay, so let me run it again. Okay, so we still have a 500 and let me see what that is. So we still have open router error. Now, see, this is where Langsmith would have been very useful, but I'm not going to go into Langsmith now. I'll go into it later. What I'll do now is just a manual print statement to print the API key. I just want to be sure that I'm actually getting the API key. Okay. All right. So let's run it and see. So you see how the 500, but API key should have been printed here. I can search for it now. Control F, search for API key. Okay, it says the API key provider is B1, B2, which is correct. So yeah, so but it says incorrect API key provided. Okay, so I think the problem is that it's trying to connect to openai.com rather than openrouter.ai. So this OpenAI API base doesn't seem to be working. So I need to confirm that. Um, okay. Right. So I made a mistake here. This was a bug. I should just type this directly instead of trying to get an environment variable that has this. Yeah. Okay. So maybe what I should have done here should have been open router API um, base. This is what it should have been. So I'm actually still pointing to OpenAI, which is what gave that problem. So this is the bug. Um, Maybe we should even change it from Open Router to just calling it OpenAI. So this way it will be um, whatever, compatible, OpenAI compatible. Yes, I think I prefer this. So I'm going to change in the um, .env as well. So we will have, all right, okay. Right. So I got this API keys correct. Right. So a little bit of debugging there. Now execute. So this time around, the fact that it's taking a bit longer means it's actually done something. So, but we still get the 500. So let's see. Name SQRT is not defined. Right. So you can see that something strange has gone on. Um, if I had Lang Smith, right, I would have been able to see what is going on. So maybe this is opportunity for me to bring in Lang Smith to just see what's happening. I requested for square root. Remember my query is, this is my query. What is the square root of 33? I am sure that the agent has generated a tool call. Unfortunately, I can't see the tool call here, right? And because I cannot see the tool call, I am not able to debug that. But my implementation of the tool call, let's go to the tools that we have. We have a calculator, so we have a val expression. This is where the problem is. And I mentioned something like this. Again, this code was generated by Copilot, you know, because I just asked it to generate a sample that I will use for this demo. This is very dangerous. You are evaluating an expression. This expression is coming from the LLM. And the LLM has given us an expression. I can print this. So let me print it. Let me print it. Yes. So that you see what the LLM generated for this tool to calculate. It is it is generating a function that requires SQRT function, and that SQRT function doesn't exist. So this is part of when we say guardrails, right? This is totally wrong. This is very bad. This is very bad. No guardrails, right? Hey, there's no guardrails because the the LLM can generate anything and you are evaluating it, right? So now let's run it again. And you see the function to call that the LLM generated. So if we go look at it, of course it will still fail. But let me search for this calculating here. See, this is the tool call that the LLM generated, SQRT33. And we're just evaluating it, right? And Python doesn't have SQRT33. It has math.sqrt, or we would have to import it. But the main thing is that we have absolutely no control over what's happening here. So this is one of those cases. And again, this is also the case where we did not do a proper handling. We did not do a proper handling of the tool call failure, right? Because we didn't do a proper handling of the tool call failure, the LLM doesn't know anything about it. We just all we just have is internal server error and it crashes. So let's do a little bit of improvement. Let's put this in a try block. Okay. Let's put this in a try block and do a tool call. Okay. Then in the exception, we return the error. We'll just return the error back to the LLM from the tool call. Okay, you try to do something and it. So let's see how the LLM will reason around that error situation that has come up here. Again, this is not very good, but that's why we say tools. Don't try to build a tool that does everything. This is the one of those cases. This is, one of those cases of a tool that does everything, which is not a good idea, right? Your tool should be specific and do specific things so that you can control. That's what we mean by guardrails. You control what it does. You control the output, and you have some error handling around the output. So, okay, good. So we have this. Now, let's run it again. So this time around, the exception, we catch it and we send it back to the LLM. And let's see what the LLM does with it. Right. So we now get a 200, which is nice. We'll now look through the messages that the LLM gives us back. So we start first of all with this. What is the square root of 33? That was my question, right? And then you have all of this that goes with it. So I'm going to ignore all of that. We'll move to the next one. Um, yeah, the next one, the content is empty. This is a response from the AI. The content is empty. You have all of this metadata. Then there should be a type. Type is AI. Then you have two calls, right? So the two calls, it asks for calculator and it generates the expression. Because remember, our two call definition was that um, evaluate, that it can evaluate any mathematical expression. So you have told the agent, the LLM, that this tool call can evaluate any mathematical. So it's going to generate a mathematical expression and send it. Okay. And that's what it did. Square root of 33. Right. But now we return a tool call response, which is packaged as tool. And we say error name square root is not defined. So we are now telling the LLM, you are giving us a wrong, you know, function to evaluate. Now let's see what it does with that. So the next time the AI responds with that, and it now, can you see what happens? It now changes. It has become more intelligent because you gave it back the error and you told it, hey, you are giving me wrong stuff. So it does a second to call. And this second to call, it changes the expression from square root of 33 to 33 raised to power 0.5, which is the same thing as square root of 33. This is the power of reasoning. And that's why we say sometimes let the LLM figure it out. Okay. So this second to call, we send it back to it. And with this, the third one, we get an answer because this is now a correct thing. Okay. Our next tool response goes that. And it now takes it and gives us the final response, which says the square root of 33 is approximately 5.7446. Can you see how amazing that is? Because what was the difference? We didn't try to handle the error, the exception for the LLM. We handled the exception, but we passed the error back to the LLM. Reason about it, okay? And then, do something with that. So, this is just step one. We'll do more things later. Let me see if I can quickly bring in Langsmith. Because the question now, you see what the number of things I had to do to figure out the error. I want to see if Langsmith could have helped us in a production environment. I will not have the opportunity to come and be doing all this print and printf and debugging code. So it's better I put Langsmith and then I can monitor Langsmith. So let's just look at Langsmith first. For you to get Langsmith, the first thing is go to smith.langchain.com. Okay. So when you go to smith.langchain.com, I have already logged in, right? So that's why you're seeing this. But if you were not logged in, it will take you to a home page and ask you to register either with your email or Google account or something. Then you go through the registration process. It's very simple. You don't need a credit card or anything. Once you register, it will send you an email and tell you to click on the link to validate your email and all of that. So the normal process. And then once you are done, it will ask you a few questions to know whether you are a developer or whether you are just using Langsmith and all of that. So I've gotten to this point where it now creates a new project, a new tracing project. So the first thing I need to do here is I need to first of all connect this. So let's go to the Langsmith. LangChain actually has um, LangChain has a documentation page to kind of walk you through that. So let me just bring that up quickly. Um, yeah, so if you go to docs.langchain.com, right? Yeah, so it gives you the steps to follow. So like I said, you go to smith.langchain.com. No credit card required. Once you create the account, you create an API key in the settings page. So I'm going to do that now. Go to settings page. So I go to settings page and create API key. So create API key, testing, lang serve, and lang smith. So the personal access token is used for authenticating with the API as an individual user. Service key is tied to a service principal for automation and CI workflow. So we'll just go with the a path first, default workspace one. When no external ID header is provided, this workspace will be used as the default. Expiration date, let's just use a 30-day. Create the API key and I'll copy this API key. I'll go back to my stuff. I'm going to just put it in here in the .m file, and it has to have a name. So for LangChain, they specify the name that you must give. Sorry, for Langsmith, they specify the name that you must give to the API key for you to be able to use it. You need to check, get started. So yes, so these are the well, first of all, I need to install LangChain. Okay, I already have LangChain and LangChain OpenAI installed, I believe. I've generated API key. In my requirements, I already have LangChain and LangChain OpenAI installed. Um, then, so these environment variables, right, that you are exporting, you can just put in your .env if you've set up .env properly. Um, so you should just put in your .env. So I'm just going to put it in the .env. And because I'm using .env, I'm not using bash directly. I don't need to export anything. Just specify. So specify tracing true. This is what will enable the Langsmith tracing. This will specify the API endpoint that your trace will be sent to. Then the API key. So that's this one I just created. So I'm going to put it here, right? So that's API key. Then the Langsmith project, right? OpenAI API key. Well, I don't need OpenAI API key. I think we already have that here. So let me just take it out. Um, this is the project. So you need to go to the project, which is this one. It could be any of them. Right. Let me open another window. smith.langchain.com. So this is the project name, right? My first app. I need to look for the um yeah, so the project name you use is my first app, which is the name that I have here, right? My first app. So I'm going to put that in here. Langsmith project is my first app. Okay. Um, so now the agent runs. We already have this code. This is already the code we have. We have the agent, we have the tools, we invoke and, tools get weather, even though this wasn't even defined as a tool, but somehow. So you can see it's very simple. Just Langsmith kind of has it built in. In fact, you find that LangChain has built-in Langsmith support. So you can see that there's nothing else I needed to do. All I needed to do was this particular environment variable to tell LangChain that LangSmith tracing is enabled and specify the endpoint for LangSmith tracing, and then specify put in the API key and then specify the project. Okay, so with this done, right, I expect that my um, UVCon should have restarted, but if it hasn't, I can just change something somewhere. Let me just change something somewhere to force it to do a reboot. So it reboots. Okay. We now have Langsmith. I can come to the project now. This is my first app. Okay. It's still saying waiting for trace. No trace yet. Trace will come when I, interact with the API. So let's do that same question again. And I'm going to try this time around. Let's just as it is with the fixed bug, but I'm going to unfix the bug again and see what happens. So this is running. You can see it's running. It does the first calculating square of 33, which was wrong. And then it does another calculating of 33 raised to power 0.5. So it's basically doing the same thing. Now, let's go to Langsmith, my first app. So you can see it's no more saying waiting for trace. It has gotten a trace. And the trace it gets from this endpoint, this slash agent that we created. So if I click on slash agent, you can see all of the things that are happening inside. This is trace first, right? You can also check other things. You can check, a bunch of other things. But look at this trace. A trace is the entire life cycle of the request from the browser all the way down across the wire to your endpoint, from your endpoint inside the code in your endpoint to any database calls and back. You have the full trace here. So without having to um, console log or print anything, I can see here already that this is agent, the input, see the input here. What is the square root of 33? You now have an output. What's the square root of 33? That's the first one. Then there's a calculator call with the expression square root 33, right? And then you see the error that goes back, the tool call that says error name square root is not defined. And then it redoes this calculation expression. And then we'll get the tool call which gives you a correct response and that. You can delve into it. You can even dig into it. So for example, this one, you can go into each of them. You even see things like the start time when the request started and when the request ended, right? Total tokens latency. You can see the tools that were called. You see that calculator, this calculator is search notes, was only the calculator that was called, right? Human input was the square root of a 3 AI is square root. This is the first attempt, okay? And then this is a tool call that came with it. Because what happens is that the response from these LLMs contain a lot of additional metadata that helps with explainability. And then you have this tool called error name square root is not defined. Okay. Now let's try something. I'm going to do the same query. Okay. But this time around, I'm going to unfix that bug. You can consider it a bug. So I go to, where is it? The tool call. Yes. So I'll remove the try catch. And just for this thing, I'm going to also remove this. I'm going to remove the try catch and the try exception. And let's go back to the way it was. So it's going to fail. All right. And I didn't log anything. All right. So now I do the API call again. Okay. I do the API call again. So this time around, during the API call, of course, we are going to get a 500 and a failure. So we'll get a 500 here. And of course, it gives us a square is not defined. But you can find out what the problem is better because you can go to Langsmith and we can look at this second API call. So this is the first one. Forget this one. This one was green, meaning it was a 200, but this is now red because it is a 500. And you can click on it and you see its name error, name square root is not defined. Trace back most recent call. And you can even trace it that this is where it got red. This is the essence of tracing because it's like a stack trace. Basically, what this Langsmith, what this is built on open telemetry, which I say you can go check it out. But what is this is doing is this stack trace that you are seeing here, as a set of text with function calls and everything, right, is turned into a graphical view of it. It contains the same thing, right? You have start time, end time. You have the input, it was expression, output, no data. It tells you this. You can check feedback here. You can check metadata. So this is the metadata, which the metadata would include the stack trace. Even though it's not probably not the entire thing, right, that gets pulled in. You can check this one and see input. Yeah, so you see again type state. This is the first part of it. Human, what is square root AI calculator. It gives the tool call. Then the tool call, this is the internal state. So with this, it becomes easy for you to figure out what happened, right? And you can then go and fix it. So that is an introduction to some of the tools I will use. So I'm going to basically put this back and we just return that. So this becomes more useful. So that's basically Langsmith. Langsmith is very easy to integrate. Yeah, the main thing you just do is create a create an account and create this API key, right? And plug this into your environment variables, which you should already have set up, right, initially. And that allows you to do everything. For me, I would even at the main, in order to also have Langsmith, I am also going to I'm going to do the .env as well. So in case I need .env anywhere else, yeah, I would do the .env here even. All right, I would do import from .env. Yeah, then I'll just run the root.env here. Okay. So that's it. Let me just round up on Langsmith. We've only done one thing. There are a bunch of things. When we come back on Thursday, we'll complete Langsmith and see what we can do with Langsmith. We'll talk about, we just looked at observability here. We are going to look at evaluation. So evaluation is the second thing we talked about, where you evaluate your app by measuring its performance. So we'll talk about evaluation and debugging. We've done a little bit of debugging already. So that's it. Are there any questions? Are there any questions? Yes, go ahead, David. You are muted. You can go ahead.
Okay, good evening, everybody. Good evening, sir. Uh, I would say the lessons are going pretty well, but it's now expanding, and I'm trying to understand how the lang serve really works. I don't know if it supports TypeScript, you know. From what I saw from Langsmith, I think they have the one for Python and TypeScript. So I don't know if Langserve support TypeScript too.
Okay, let's try that. Okay, we can try that. So for your information, remember, Lang service used as a server, right? So you're not planning to use it on your browser. You're going to use it with Node.js, okay, as a way to serve your um your agent as an endpoint. You're basically using it to make a backend. You understand? Okay, so let's see. I know you're always asking about JavaScript. Yeah, so what I'm saying, you cannot run langserve inside a Node.js server, right? So what that means basically is that if you want to do your Node.js backend, you have to do it manually. But I think you can pull in, there's a langchain.js, but that one is for client side, okay? It's not for server side. So if you want to do a Node.js backend that serves your agent, via an API endpoint, you basically have to do it the way we were doing it before, where you would be able to do the agent with lang chain, TypeScript, okay? But when it gets to the endpoint, there's no shortcut to say, okay, because remember what langserve is basically doing for you is just to allow you to, it creates those endpoints for you. It is not langserve that is creating um the observability. You need to be clear. I actually taught two things today. I taught using langserve to serve your agents. Then I taught observability. Observability comes with lang chain, not with langserve, right? So you can still do observability, right, with the lang chain and set it up, but you have to manually um, set up your API endpoints, basically. I hope that answers your question.
Yes, sir. Yes, it does. It does.
Okay. So let's just talk a little bit about, I think I've talked about the capabilities of Langsmith, right? Langsmith, um, we've also seen what it does. We just looked at tracing, okay? Tracing solves the problem of why an answer was produced. So as you can see, with Langsmith tracing, you can see every step of the way, what was happening, okay? Tool usage becomes visible. Without tracing, you will not see where tool calls are made, right? But with tracing, you're able to see where tool calls are made. Failures are easier to debug, right? So every single LLM call, every tool call, every prompt, every response, every latency tokens, you can see everything. That's what Langsmith brings for you, right? But the interesting thing is that with Langsmith, right, LangChain automatically traces all of those things. Because whenever you are using LangChain, you are using chains, you are using agents, you're using tools. So there's tracing enabled internally in all of those um, you know, primitives, if I use that terminology, because yeah, but you have to use the LangChain version of it, of course. So LangSmith will automatically trace the agent's reasoning step, the tool invocations, the RAG retrievals, latency, token usage, and all of that, like we saw. Okay, so that's the benefit of tracing. Let's talk a little bit about evaluation. We're going to look at it more. The main thing with evaluation is for you to know how well did your model perform. Tracing is to debug and find out why did it fail. But evaluation is how well did it do. So did the agent give you the correct answer? Right? Is it grounded in retrieve documents if you are using retrieval augmented? Okay. And is it helpful? So those are the things. And there are four different types of evaluation, which we'll look at when we come on Thursday. But this is just kind of preview. You have the automated evaluation where you are using the LLM to even judge whether it did well or not. You have a heuristic where you manually write it, and that one LangChain provides a way to do that. And then you have human, where you yourself as a human or your users can rate and decide. And then you have regression, where you compare the current output with previous output to see if maybe between last week and this week, whether the output has changed. Okay, so those are some of the things. We'll talk more about evaluation. I don't want to keep us any longer than this. We'll recap the whole um evaluation when we come in. And then secondly, so David, what I will do to help you on JavaScript is to do the same thing, but with Node.js and see how we can achieve the same thing, including the tracing using LangChain and Node.js. Of course, you will not have LangServe there, but you can write the code yourself. Okay. So that's all from me. And yeah.